Hello, everybody, and welcome. Thank you for taking the time to attend this session. I feel very humble and honored to be here today to talk about non-English search as a machine learning problem. My name is Ramzi Alqrainy. I'm a CTO of a company called the Chefz, which is a reservation system and food delivery running in Saudi Arabia, focusing on elite restaurants and elite users. I have a master in artificial intelligence information retrieval, focusing on Arabic language, contributor on Apache Solr, contributor on Slack, technical reviewer for 4 books related to the Apache Solr, Hadoop, Spark, and others. In our company, we focus to provide our users a seamless experience to enjoy their journey for exploring new restaurants and finding a proper restaurant to order. So focusing with Arabic culture, based on the data that already built on Arabic content, you will face a lot of challenges that you have to deal with. As a start, as Arabic today is the 4th spoken language globally. So imagine in 2017, the Arabic-speaking internet users were 135 in 2000 million users. In 2019, 225 million users. So it's almost the double. You see, in the shortest time, you see the huge increase on the Arabic internet users, with also the Arabic content with less focus of handling and tackling the challenges related to the Arabic content, especially that we have a less research on that part. Arabic language poses many challenges for retrieval when dealing with the social media, such as microblogs and informal web content, such as a discussion and forums. These complications related to the use of text decoration, abbreviation, and other challenges. I can group these challenges into 5 challenges: orthography, diacritics, morphology, dialects, and Arabici. So with the first challenge, which is the Arabic orthography and the print. So Arabic has right to left connected script that uses 28 basic letters. So imagine the same letter has many forms based on its location in the word. So beginning, middle, end, and separate are completely different. This is one of the example called Ain, the letter of Ain. You see different shapes and forms based on the location in the word. Another challenge that we need to talk about is Arabic diacritics. So Arabic diacritics help the imprecate of the meaning of the word. So for example, the word of alam means flag. Ilm means knowledge. The same word, the same letters, but different diacritics, you will get a different meaning. Common search engines in the world, they use the approach of removing the diacritics to simplify the retrieval, but this will affect the relevancy of the documents. Here, you have to understand the context of the word so you can understand the meaning of it. Here, the complexity of handling Arabic language comes from the morphological variation. So you can generate several words from common root. So Arabic words are divided into 3 main types: noun, verbs, and particles. Imagine one of the words like kataba, write. You can see kitab, book, katib, writer, maktub, written, and kutayib, small book. This will add more challenges for analyzing or retrieving the word to the root, which is, we can say it, going to add more complexity for analyzing these words. On another hand, Arabic dialects is another challenge. So Arabic dialects started finding their way to online social interaction. So there are 6 dominant with many variations of them and dozens more lesser spoken dialects. Of course, there are several factors that make dialects different, make different lexical choices to express the concept. So the concept corresponding to I want, in Egypt, they say it عاوز. In Gulf, say it Abgha. In Iraq, say Abi. In Levantine, which is Palestine, Syria, and Jordan, Lebanon, we say Biddi. This another way of dealing with the challenges that you have to add it into consideration, that you see the importance of the synonyms is very important. The last challenge I can mention here is Arabici. The new generation of the people, the Arabic internet users, they start talking using the Arabici methodology, which is using Latin character and transliterated with the Arabic character. So sometimes they use 2 represent to alif, 3 represent to ain. This is a list of the Arabici that they are using with the examples. Here you can see a lot of challenges related to the Arabic language. Now, let's think about the problem with the classic model of relevance. The core of algorithm of the search is called TF-IDF, and Solar uses an algorithm called BM25 that improves upon TF-IDF. But basic idea is the same if a distinctive term appears more frequently in a document and that document is more relevant for that term. This is good enough for most search of most document collections. However, there are times when just looking at keywords are not enough to accurately capture user intent. BM25 algorithm is a good general purpose scoring model that proving of it, it's somewhat difficult, especially in a global systematic fashion and not in an ad hoc case by case whack-a-mole basis, but perhaps for your enterprise, there are many valuable businesses, specific non-keyword based relevant factors you want to leverage. In these cases, keyword search just is not enough. So one of the ways with Solar to address this problem or relevance is through an algorithm called learning to rank. Learning to rank is a machine learning technique where we teach the computer how to rank items. We do this by choosing features which you can think of this as a relevancy factor that we think the algorithm should weight and tune. We also need a source of ground truth or order one source of this is user behavior. Luckily, Solar provides some nice basics building blocks for implementing learning to rank, and we need to capture user behavior as well as pipelines for applying these techniques in order to understand learning to rank. We use machine learning to predict whether or not a query like, for example, an iPad is relevant to a document. The feature is used to feed the model are similar kinds of relevance factors that you would use to feed a solo ranking function. Things like the score of title matches or a score of body matches or perhaps the number of views document has, similar to how a spam classifier learns from training model data in the forms of email, learning to rank models are trained in the same way or with a ground truth relevance label. First, we need to decide which feature to feed the model. You could think of a feature as a relevance factors like a title match, score body match, or signal-based feature. For example, if you use, for example, a fusion, you can use the signals as a create ground truth of clickstream data. Ground truth is simply a large list of queries and most relevant document for each query. Lastly, we use Solar learning to rank to help us training learning to rank model. In a traditional search tag is based on a bit on information retrieval where you have two main processing stages. You have the offline part and the online part. So offline, you say acquire a set of document, some sort of document, you whether web crawl or you kind of get them, the user and whatever, depending on your application. And there is a lot of kind fuzzy and putting metadata engineering Sometimes that's very hacky, where you do just scripts to clean up your data and kind of put it into your index. And a lot of Lucene and Solar already does the representation functions and how you represent each of the field on your document as separate columns. Then you create an index with an invert term frequency so that you could quickly retrieve the document, the different documents. So that all happens offline. Now, online, represented as a function that gets passed into as a query, then there is some sort of similarity, typically TF IDF, then retrieves the relevant document. And the part in the purple is where more and more of the state of the art is moving, where we are going to not just have a stagnant similarity calculation, but we want to have a relevance feedback based on the history of what a user clicked. So say I'm searching for shoes, maybe, and I really like certain types of shoes, and then just to my taste will tune the relevance to me, and let's say shoes for someone else, they are gonna look for combat shoes. So that part is now a lot of its moving, and where the power having Lucene's open source and Solar, we can start taking the advantage of that. Combined together, we have this utilized model that we trained earlier, then we can put it in the plugin. So then effectively in search, and we're gonna do the phase 2 of ranking, of re-ranking together in it. So what this means is that you are effectively doing the evaluation of the model of the ranking inside search, and 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 you can do that because Lucene, you can plug in the engine. So what we have here is how this machine learning scoring architecture work, which the phases of filtering and ranking would all happen in one step. Here is the big your workflow of how implement learning to rank in this diagram. It's going to start with the step number 1 in the lower left and follow where the arrows point. So number 1, we upload a set of features to be Solar JSON REST API. Next, using any solution for ground truth like Fusion Signals, we produce a ground truth ordering of your results. And once we have that, we can use a Spark job to extract features, your vector for each query number of feature vectors are then used to serve the feature vector service input to our model trainer. Number 5, once the model is trained, we upload it to Solar. And 6, lastly, user will see the results in order provided to by our learning to rank model. Here, training a few different models, namely a straight out-of-the-box Solar and textual features only. The logistic regression model using all features except signal feature, and logistic regression model using all features including signal features. The performance metric we used in this graph is recall at 5, which is simply for a given query, our percentage of relevant documents appear in the first 5 results, average over all queries in a held out test ground truth set. The signal feature applies a query aware of boost document that are more frequently clicked or purchased. The learning to rank model will automatically wave this feature along with all other textual features in order to maximize relevance according to our metric. As you can see from the graphs, there are significant relevant improvements observed over out-of-the-box solar BM25 ranking, and even over the logistic regression train model when using signal features, while the goal of this tutorial to demonstrate how to implement learning to rank and not necessarily how to reproduce the most accurate model. And thank you.